Okay, so 2 more minutes to go, so we will start at 10:10. Okay, let's start. So today's tutorial, we will be talking about 3 questions from the assignment. Yeah, so let's start. Okay, so first of all, it is question number 5. So let me define a couple of concepts first. So we are using variables to represent a proposition, right? So unlike mathematical variables, where a variable is usually used to represent a integer value or a real number value or mathematical value, here the variable that we are talking, they are called Boolean variables. These are variables whose value can either be true or false, but not both. Okay. Now, using Boolean variable, we can make up a formula using them. So if it is a formula made up with Boolean variables, we will call it a Boolean formula. So the operators that we are using will be something like the logical operators, and or not, imply, whatever. So for instance, here we have an example. So in this example, you will see that there is a certain formula which reads x or y, x or not y, and then another part which is not x and bracket of y or z and closing bracket. So this is another part. So we have and together. Now each of these variables, we will assign a true or false value of them. So once the truth value of each of the variables are known, then we will know that the formula will be true or false based on it. And then we will talk about satisfiable of a Boolean formula. So a Boolean formula is called satisfiable if there is a way to assign the true or false value to the variables, such that the whole formula becomes true. So for instance, in this particular example we see before, let us try to plug in the case where x is equal to false, y is equal to false, and z is equal to true, and we will see what will happen. So when x is equal to false, y is equal to false, this part, x or not y, will be false or not false, which is equal to true here. This part is equal to true. Now let's look at the other part. So when x is equal to false, then this is true, and this is true. So this part is true. Y or z will be true. So not x and bracket of y or z will be true. So this part will be true. So in that sense, we will have this part is true and this part is true, so that the overall formula is true. As long as we can find a particular case by plugging in the variables of x, y, z, so that the formula becomes true, then we will say that the formula is satisfiable. On the other hand, if for all possible assignments, for all possible cases of assigning true or false value to the variables, we cannot make the formula true, then the formula is called not satisfiable or unsatisfiable. Now, this question in homework 1 talks about this concept. So in particular, this is the first part, case A. We want to show that this expression, this formula, is satisfiable. Now to show this, it is rather easy. We find a particular case where it is true overall. So we will see that by plugging in P and Q to be both false. Now the first part here is P or not Q. So this is true because not Q is now true. And then this is the middle part. The middle part we have not P here because P is false. So this is true, true or anything is true. So the middle part is also true. And lastly, this part we have not P or not Q. So not P is false. So not because P is false, not P is true. So this part is also true. So using this assignment, P and Q to be false, we will get true and true and true. So in summary, we will get true overall. So this is a case where we can make the formula true. So in that sense, the formula is satisfiable. And let's see another example. This time, we want to show that this expression, this formula, is not satisfiable. So how do we show this? So there are actually two ways. Yeah, the first one is to show something is not satisfiable. We can always use a truth table to do so by listing out all the possible cases. So P true, Q true, P true, Q false, P false, Q true, P false, Q false. So there are 4 cases to consider. And then we will see that no matter which case we are talking about, the overall expression is false, then in that case, it is not satisfiable. So this is method 1. And then method 2 is we can also try to, so if you find the truth table is tedious to draw because it is perhaps very large, then we may argue this is not satisfiable by using logical arguments. So here we will see that we have 4 parts. P implies not Q. Sorry, the first one should be P implies Q, I think. And then P implies not Q, not P implies Q, and not P implies not Q. So there's a typo here. So this P implies Q. We will see that no matter what happens, one of these 4 things. Oh, let me do the correction now immediately so that you won't be confused. So this is this one instead, okay? So we have actually 4 things to see, but we will see that no matter what happens, one of these parts, P implies Q, P implies not Q, not P implies Q, and not P implies not Q, one of them has to be false. Because one of them has to be false, and then we have 4 parts and together, so we will see that no matter what happens, one of these 4 parts will be false. So in the summary, the overall formula must be false. So no matter what happens, the overall formula is false, so that means that it is not satisfiable. So we can also show this is not satisfiable by using this kind of logical arguments. Now the problem of deciding whether a formula is satisfiable or not turns out to be very, very hard. So this is one of the famous problems in computer science. So at this point, nobody has got a very efficient method to check whether a formula is satisfiable or not. One can only nearly rely on something like we check all the possibilities and see whether there is at least one case to make it true. So this is one of the open problems that computer scientists are trying to solve, and then very famous. So it is like worth $1 million if you can prove that there is no efficient way of solving this problem, or alternatively, you can find an efficient way of solving this problem. So it is you can obtain $1 million from the Clay Institute in US. Okay, now let us talk about question number 6. Okay, now question number 6, we define a new logical operator called NAND, N-A-N-D. So the symbol is an up arrow. So the definition of NAND is like this. So let's say you have proposition P and proposition Q. The operator P NAND Q, it is going to be false if and only if both P and Q are true. So that means that it is going to be true if either P or Q or both are false. Is that okay? So you can see that this is kind of like the opposite of the AND. Yeah, because for AND, it is true when P and Q are both true. And here, P and Q is false whenever P and Q are both true. So in that sense, P and Q is actually the same as equivalent to not P and Q. So we obtain P and Q, the value of P and Q, and then we make a negation, and then we get P and Q. So that's why we call it NAND. The first one, N, means not. The last part means N. This is not N. So to show this is true, we can use the truth table to do so. And then the question in the assignment actually asks us to see if we can express not and or these three operators by using NAND, NAND only. Now, so one of the parts gives us already the solution for how to obtain not. So to obtain not of a proposition, we just get the proposition and then NAND itself. So we will see that P NAND P actually will be equal to not P. Now to show this is also very easy. We can draw a truth table and then find that it is correct. Now once we have this not, and then originally we have NAND. So not and NAND together can easily combine to get an AND. It is very simple. This time we do not need to get the truth table, or we do not need to guess the formula directly. We can combine the result that we know so far and then get the correct formula. So here, let us start with P and Q. So P and Q, what we know is it is the negation of P and Q, right? Yeah, so we get P and Q, and then we get the opposite, so it becomes AND. Now, so this part, this is the negation of a certain expression, right? So the previous part is not of a certain expression is simply the expression NAND, the same expression. So in that case, we will obtain P and Q is equal to this part. You get the result of P NAND Q, and then NAND itself. So you get the AND. Now notice that this is the final thing that we want, because if you look at this whole expression, we are just using this NAND operator. There is no other operator we are using. So that means that we can express AND simply using the NAND operators only. Okay, once we have AND, then we can get OR. Okay, now this is AND. So how do we get OR? Okay, so let's see. Maybe we don't need to have AND. Okay, so maybe this is something extra. So, but let's see. So this is OR, P or Q, right? Now, by using the De Morgan's law, P or Q is the negation of, so we negate the negation of not P and not Q, right? So if you double check whether this is true, because there is a negation. So when we get negation at De Morgan's law, not P becomes P and becomes OR, not Q becomes Q. So the negation of not P and not Q is exactly P or Q. So this is not, this is AND. So this is simply the NAND thing. So this whole expression can be translated into not P, NAND not Q, right? So we have not P, NAND, not Q. We know not P. Not P is what? Not P is P NAND P. So what is not Q? Not Q is Q NAND Q. So in that sense, we will get an expression for OR. So this time, once we have P, once we have Q, by plugging in P and Q here, we get this whole expression is equivalent to P or Q. And then this expression is just using the NAND operators only. Okay. Now, there is a famous result. It says that any Boolean formula, so we are talking about Boolean formula, right? Any Boolean formula can be expressed into a Boolean formula by just using and or not. So even if the Boolean formula is very complicated, even if it includes something like the imply, something like the exclusive or some other strange operators, then no matter what happens, there must be a certain Boolean formula which is equivalent to what we are talking about, and it just uses and or not. And now we see that and or not themselves, each one of them can be replaced by using NAND operators only. So what do we have? So we can have a theorem that says every Boolean formula can be expressed into an equivalent Boolean formula such that it just have NAND operators inside. And this is something which is also very important because in the electronics industry, when we are designing these small chips, IC chips, we may be using this NAND as a component inside. So by just making use of NAND operators, making the NAND operators the NAND gates, we call it. So when you talk about electronic circuits, there is something called NAND gates, which do something the same as the NAND operator. Then we can design a circuit, an electronic circuit, that can do logic performance for any types of decision, any types of logical expression. So we call this NAND a certain kind of a complete operator. So it can completely describe any types of Boolean expression. Okay, so this is question number 6. And question number 7 is actually easy, but let me just place it here for completeness. So here in this question, we are seeing this kind of thing. So someone write down a proof that says, suppose that we know that there exists x is true. And then let's say the domain of x is all people in the class, okay? And then there is a certain girl whose name is Lola. So we are trying to jump into the conclusion. Suppose that this not there exists x is true. Suppose this is true, then we can jump into the conclusion that h of Lola is true. Now somehow you will see that this is wrong. What is the reason? So yeah, to explain something that is so obvious is difficult, right? But still, let's say you are having a younger brother or sister, and then he or she wants to know, yeah, why this is wrong. Then perhaps you will still need to make it even more easier for them to understand. So this is how I would explain. So in my explanation, so I will first describe the meaning of what is meant by there exists x is true. So there exists x is true. It only says that some of the x here inside will make hx true. Now, this x can, of course, it can be Lola, but it can also be anyone else. And because that this x do not specify which person is making it true, so that means that we cannot jump into the conclusion of h of Lola is true. So by jumping it into the conclusion, we are actually pointing out that it must be Lola. But here, there exists hx only talks about somebody. So it could be Lola, but could also be someone else. So we cannot jump into the conclusion. Yeah, I hope this is somehow easier for people to understand why this is wrong. Okay. And okay, so there are some, so I've demonstrated three questions and then the answers, yeah. But then in the assignment, there are other questions that I want you to try if you have time. So question 15 is about the definition of limits of x tends to x0, f of x is equal to L. What does that mean? So this is a perfect example of understanding the how do you use a logical operator to do the translation of a certain mathematical concept. And then for this question, yeah, so it is much easier if you start by writing down the expression with shorthand notation. So don't worry if your expression contains shorthand notation, because that will make your mind clearer. But after that, once you have written down a correct expression with shorthand notation, then you will want to try to remove the shorthand notation and then making it into the standard form. So this is a good practice of doing the thinking and also doing the shorthand notation conversion. And now the question 19 itself is very confusing if you read it, but then yeah, try your best to understand what it is trying to ask you. And then it is also fun after that to solve it. Now for this particular question, there will be one solution that you can find. And then to challenge yourself, actually, you can also show that this is the only possible solution. So no other cases will make this question to be solved okay. So once you have got a correct solution, yeah, also show that why it is the only solution. Now question 20 is a logical puzzle, but it is not difficult, it is rather easy. Yeah, to solve this, just try to list out all the possible cases, just like using a truth table to prove equivalence. So here, by checking all the cases, you will be able to obtain the answer. Now question 21 is extremely challenging. So you may ask us for some hints, but then we will never give you the solution for this. Yeah, because yeah, we find that it is much better for you to solve it by yourself. So it is rather pointless if we give out the solution, because yeah, the purpose of this question is for you to think, and then see if you can get it. So it is extremely challenging. So if you have time, yeah, solve it. None of them are very important for your upcoming exam. It is because every questions that you see will not appear in the exam. So don't worry if you don't know how to solve it, but at least we hope that the assignment here will help you to understand more about the concepts discussed in the class. Okay, so that's all for today. Yeah, if you have any questions, yeah, please leave us your question through the questionnaire form. Okay, otherwise we will see you again on Wednesday. Yeah, thanks again for coming on such a holiday. Okay, happy holiday. Thank you.